All right, welcome to day 3, industrial workplace safety. Again, today we're talking toxic and hazardous substances. So just kind of a continuation of day 2 in hazardous chemicals. When we deal with hazardous substances, science of industrial hygiene, we have to anticipate, what those substances are, recognize any issues, recognize what the hazard is in itself, whether it's a touch hazard or a breathing hazard or whatever, and then evaluate ways that we can possibly fix it, and then control it at the end. And again, it says anything that might cause sickness or issues. It says identify 3 forms of health hazards, identify routes of exposure, and then we'll talk about the tables a little bit. Again, those tables would be in the OSHA 1910 manuals, which are not a required textbook for the class. Anticipating the hazards is our first step, like we said. So we need to know the forms the hazard can take. Is the odor a hazard, or is there no odor to it? Natural gas has no odor. The smell that you smell with natural gas and propane, for that matter, is added to it so that we know when there's a leak. Be familiar with whatever you're doing and the health hazards that would be commonly associated with it. Somebody who deals with acid every day, knows the effects of hydrochloric acid, let's say. Familiar with the OSHA standards, again, what the rules are, what we can do, what we can't do, and then, take proactive steps to, again, control those, health hazards or any new health hazards. And like it says, the clues over on the right side, odor, you may smell something, taste, again, you may not put it in your mouth to taste it, but certain chemicals in the air will give you a taste in your mouth. You should be familiar with those. Acute symptoms are symptoms that come on right away. And then dusts or particles in the air can certainly be an issue. And the 3 forms of health hazards, solids, liquids, and then gases. Simple enough there. But when we talk about, even solids here, particulates, fumes falls kind of into the gases. We talk about gases and vapors or fumes. A fume comes from something in excess of 2,000 degrees Fahrenheit. Kind of an interesting one there. But when you think about welding operations, we get welding fumes off of the metal as we're welding them together. Okay, put in lots of ventilation systems for welding operations, again, to try and ventilate the area. So those fumes aren't being breathed in by whoever's working there. And then dusts, again, solid particles, crushing, grinding, blowing things up, breaking things apart, can create solid dusts. And then, it also talks about respirable dusts, which means, small particles, that can get deep into the lungs, when you inhale them. Again, it kind of shows on the little chart here, they get visible above about 50 microns. Below that, you can't even see them when you breathe them in. And there again, then they can get deep into the lungs and cause damage. Mists and aerosols, it says, suspended liquids. You breathe in a mist of something, it can condense even inside your lungs and cause issues. Then it gives a couple of examples. Acid mist from electroplating, you can't really see that. Such small, particulate matter that you normally can't see it. So you wouldn't, you just have to know that the danger was there. Then they list oil mist from cutting and grinding. Occasionally, when you're using cutting oil on a process like this, you can see the little cloud of mist that is created. Again, you're not going to stick your nose in it and breathe it in. It's pretty hazardous, right? Then it also lists spray finishing. Again, anytime you've ever been in a paint booth, or if you ever see anybody in a paint booth, they're in a cloud of liquid paint that's floating around. wearing a respirator to keep that out of their lungs. Then on the right side, they list fibers, commonly used in construction. Like it says, it lists the examples: asbestos, fiberglass, asbestos or fiberglass. The other one I think of when I think of fibers is flyings, which tends to be things that don't quite meet that slender, elongated shape, several times as greater than a diameter. I think of cotton fibers. When you're processing cotton, those tend to be referred to as flyings because they're smaller than what a fiber would be. Gases and vapors then on the bottom, a good little, not necessarily illustration, but a couple good statements there about a gas versus a vapor. Gases, are in their gaseous form at room temperature. And it says there, chlorine, and fluorine are gases that are, present, during the work process. They're in a gaseous state from the very beginning. Whereas vapors are gases that are formed when, some particular liquid evaporates. And again, they list gasoline as a possibility there. Open a gas can. There are some vapors that come off of it. Ingest too much of that, again, you can get sick or ill. And then it also lists there at the bottom, solvents with a low boiling point, form vapors more easily, at room temperature. So the lower the boiling point, the bigger problem there is with vapors. And here's a list of common processes and the health hazards that come with it. It says, heating using microwaves, melting metal, metal fumes and dust. Again, I'm not going to go through them all. If you look at the handout pages in day 3, these are in there. Mixing dry materials is one of them. Think about cement, sand, and gravel. Pour it all into a bucket or a wheelbarrow or whatever. You've got some dust involved there. Then when you add the wet material and start to mix it up, you still have a problem with the dust. So, again, some potential hazards that are there. There's a whole list, including handling small parts. Carpal tunnel and repetitive motion has become a big thing over the last 8 or 10 years as we've discovered that there's issues. Then they list some of the coating processes, even the explosive process. If we're blowing something up, imagine that. There's gases from the explosion, carbon monoxide, and dust from the rocks or whatever that we're blowing up. And then even in warehousing, there's carbon monoxide from any machines that we might run, chances of nitrogen oxide, and then also, chemicals. So again, look through that list, and if you don't quite understand something, just let me know. And then recognizing the hazards comes up. Okay, so what is the hazard? Is it a chemical hazard? There again, we're familiar with certain chemicals, like we talked about earlier, chlorine, bleach. There's also, even isopropyl alcohol or hydrogen peroxide or nail polish remover, which is acetone, acetone-based at least. Those are all chemical style hazards. And it says they can be liquids, gases, mists, dust, fumes, or vapors, or even solids that are the hazard. If we identify all the chemical hazards, then what about the physical hazards? Again, noise comes up a lot on that list on the previous page. I find myself wearing my earplugs more and more the older I get. Temperature extremes goes to what I talked about, working in the cold, or extremely hot areas. I've worked 10 below zero, 300 feet in the air outside. I've worked at 120 to 150 degrees above a paper machine. Those are temperature extremes. They take some recognition so what proper clothing there is. Then the third one is ergonomic. Again, carpal tunnel style, repetitive motion, heavy lifting, hard on the back, things like that. Then they also list psychological things there, monotony or overload. Even doing the same job over and over again, that repetitive motion might be physically bad and psychologically bad, because you're doing the same thing constantly. And then the last one they list is biological hazards, and there's our little biological symbol as far as the safety symbol goes. Again, when I think biological, first thing I think of is bloodborne pathogens, but any bacteria, virus, can be a biological hazard. In addition to, and it shows their insects, plants, and animals. Again, if you're allergic to certain plants or animals, there, is some biological hazard that at least is the potential there. One of the next things is then, okay, we got to recognize the toxicity. We know that we've got a chemical that we're exposed to, but how damaging is it? Exposure for 5 minutes damages the liver or kidneys. Stops the body from forming, blood cells, or upsets your stomach. What level is it? What's its level of toxicity? And there again, on the right side in the gray box, they list some of the toxins. Cyanide is a chemical one. Radiation is physical, and then, like I said, biological. First thing I always think of is bloodborne pathogens. And we know that it's toxic. We know that it's bad for you, but how much of it is bad for you? Again, saccharin was a sweetener that was used back in the 80s. When they have to give, I don't remember, it seemed to me like it was crazy that they banned the stuff because it was like 50 pounds of saccharin to kill a mouse or kill a rat. But we have to make some sort of determination. So, how many times do we dose? What's the concentration? Is it pure cyanide or is it something else? How often are we exposed to it? And how long are we exposed to it? So both frequency and time period there. And, it says 1 microgram of botulin can kill 20 million mice. That's a pretty toxic chemical. Okay. Health effects, we have to look at, is it going to harm part of the body that's contacted, so I touch it and it irritates the skin? Or is it systemic in that I touch it and then it, absorbs through my skin and into my bloodstream and kills my kidneys or whatever? Is it an acute health effect problem in the fact that, very limited exposure for a very short time can, cause severe effects? Or is it a chronic health effect type thing? Asbestos was deemed to be a chronic problem. After years and years of inhaling asbestos dust, people got cancer. So now asbestos is one of those products we have to be careful when we're handling it. And it says, here, the dose makes the poison. Again, looking at the chart here in the bottom right or middle right, sugar, simple sucrose, table sugar, takes 29,700 milligrams per kilogram that a person weighs in order to be toxic. And that's kind of what that LD50 say. Lethal dose 50%. It's the amount of a substance per kilogram of body weight necessary to kill 50% of the experimental animals in a toxicology test. So alcohol, 14,000 milligrams per kilogram is going to kill half the people. Table salt. Again, you can see some things listed there, even aspirin, that we use on a regular basis. Caffeine, 192 milligrams per kilogram. Down to, the botulinum toxin, that is what, 0.00001. So 10, what would that be, 10 picograms per kilogram can be lethal. And then we also have to remember, bullet 2 here, number 2, the effect on an individual, can become more severe over time. And that's where they call, dose response. We get a dose of, table salt every day. Eventually you develop less of a tolerance for salt. And that's kind of what the dotted rectangle here at the bottom is. As the dose of a toxic chemical is increased, the effect on an individual becomes more severe. It doesn't matter whether we're increasing the dose or we're increasing the time exposed, those things will both have an effect and cause more severe reactions. Then recognizing the route of exposure. How do we get the chemical? They list 4 here. Absorption through the skin. It says absorption, or it says skin's the largest organ of the body. We absorb things through the skin. We can inhale them through our lungs, through our nose and mouth, breathing in dust or airborne chemicals. Ingestion, again, I think it was last time in day 2, right? And that guy that drank the antique black out of the Gatorade bottle and died within 2 days. So we can ingest things. And then the 4th one is injections. Again, made more aware of the fact that, needles can carry diseases, hepatitis B and HIV, so, don't use dirty needles. But when I think about injection, I think more about the bottom little paragraph there. High pressure spray equipment, compressed air. I know when I was little, I think I was 10 or 11, my uncle was using compressed air, blow off dust off his arm, and actually shot a piece of rust, we guess, underneath his skin. Within 2 days, his arm was swelled to about twice what it should have been. It's never a good idea to use high pressure spray equipment to, and point it at your own skin, is what it comes down to. And it says even low pressure equipment can result in tissue injury. Then at the very bottom in the rectangle there, it says the 5th route is the eyes. Most people don't consider it a separate one, and I think it says it there. It says it's unusually high absorption capability. It's sometimes described as a route of entry. The key is it's absorbed through the eyes, so it falls into number 1 there. Whether it's absorption through the skin or the eyes, the only real difference is because of the makeup of the eyes and the liquid that's present, it absorbs things, faster than it would be absorbed through the skin. But it's still an absorption method. And so again, just like we had a list earlier, here's a list of different health hazards and things we should recognize. Some of them we looked at before, like number 9, mixing of dry materials, and mixing up the dry concrete mixture before we add the liquid. There's dust that's being created. Once we do add the liquid, there's still the potential for dust. We talked about grinding and explosive processes. Just a list to look at and think about, again, in the handout on day 3. Once we've recognized all the hazards, then it's time to evaluate what's going on. How long is the exposure? Where is the exposure? Can we limit it? And so, it talks about in the little gray box about the breathing zone. Very good example. A 6 to 9 inch hemisphere or ball or globe. Forward of the employee's shoulders is the area that you're breathing in most of your air from. If we can keep that area clean, we shouldn't have any inhalation problems. How do we know what kind of problems we have? Monitoring. Maybe we're in an area where occasionally the atmosphere becomes explosive and dangerous in that way. We can monitor that. Or we've got concentrations of dust and fibers that are unsafe. Again, we can monitor that. Then on the right side, they talk about specifics. Carbon monoxide, or CO, is something that's been a big deal in the last couple of years as well. They want to make sure everybody's got a CO monitor so that they don't get carbon monoxide poisoning when their furnace malfunctions. Or we can have a sensor there for oxygen deficiency. When you enter a confined space, you always have to have an oxygen deficiency meter so that you know if all of a sudden the amount of oxygen in there is going down so you can get out. A few other things, again, monitoring methods. We can monitor blood, urine, or breath to keep track of person's vitals or how healthy they are. And again, we can put in filters, or other things to help keep the area clean. When we talk about exposure, and again, that evaluation process, we have to evaluate the permissible exposure limits. Again, the top half talks about PELs and TLVs. PEL is that permissible exposure limit. OSHA has a list of chemicals that we have exposure limits for. Okay. then, and those are legally enforceable. Okay, if you're exposed to that, greater than that, on a regular basis, OSHA could fine your employer. Then we also have guidelines on products that, OSHA hasn't made a code yet, so it's strictly a guideline. Guidelines are not enforceable. They're not finable. They're a voluntary thing. Don't expose your employees to this or they might get sick. Then as you go down to the middle of the slide, it says most OSHA PELs, or permissible exposure limits, are for airborne substances with allowable exposure limits of about 8 hours per day for a 40-hour week. And that is your TWA, or time-weighted average. Then there's also STEL, which is short-term exposure limits. And then there's a ceiling limit. So I talked about working in a nuclear power plant in the day 2. Again, you wear 2 badges. One is your ceiling limit badge, or the maximum amount of radiation you can be exposed to. The other one is your TWA, the amount that you can be exposed to today. If your today badge turns black, you get to go home for the day. If your ceiling limit badge turns black, you are done. You are no longer employable in a nuclear power plant. And so, a couple different things there. How does OSHA determine what the permissive exposure limit is? NIOSH, the National Institute for Occupational Safety and Health, researches hazardous materials and makes recommendation to OSHA. And so once OSHA makes it a rule, or makes it a code, we'll say, then it is an enforceable exposure limit. Until then, when NIOSH is investigating it, or once they've made their determination, it's a recommended limit. So again, manufacturer says, hey, you shouldn't be exposed to this for more than 6 hours a day. That means, that's a recommended exposure limit. NIOSH would then investigate that and see if they agreed. And, eventually it might make it into an OSHA code. Okay. And so it says, threshold limit values are similar. They're guides. They're not enforceable. They existed prior to 1970, and those that were in place in 1970 were the ones that were adopted. It says it jump-started its regulations by adopting those ACG, IH's existing occupational health guidelines. Again, TLVs, time-weighted average, short-term exposure limit, and ceiling limits turned into OSHA's PELs, permissible exposure limits. Then the final step is, how do we control the hazard? We know what the hazard is. We know what exposure limits they are. So now let's look, can we use a different chemical? Can we get rid of that hazardous chemical altogether and use something else? Can we reduce the hazard? Replace it with something else like ozone, still harmful, but not as bad as chlorine, so let's change it. Can we enclose or confine the workspace? Sometimes not even close to possible. And then the last one, can we eliminate it by installing local ventilation systems, welding hoods, where we're sucking the the welding fumes out of the the area as quickly as possible. Then there's administrative controls, something very as simple as saying, okay, Joe, you're not going to run the jackhammer for all day today. We're going to split it up. Each one of us is going to run it for an hour. So we split it up among 8 people for an hour, or even 4 people for an hour, 2 different times a day, so that we're not doing the same thing, breathing that same concrete dust, for the whole 8-hour day. Or, possibly do it at a time when there's fewer people around. We don't, strip and re-wax the floor in the middle of the day. Do it in the middle of the night when, there's only 2 or 3 people there, only the maintenance staff. Limits the amount of people that are exposed, and then we can also provide them with extra personal protective equipment so that they have sufficient amounts. Work practices, can we we need to inspect and maintain our equipment so that it is in good working order. We need to have good housekeeping procedures, make sure everything's kept clean. If we spill a chemical, there's got to be a process to get it cleaned up. Effective supervision always helps. supervisors knowing the dangers and what it may take to limit the exposures. And then simple, not allowing eating, drinking, smoking, applying makeup in a regulated area. If there's acid chemicals that or we'll say acid vapors that are there, I'm certainly not going to be eating my lunch and breathing in and eating acid vapors at the same time. So, just good common sense things can help there. And then the last step is PPE. PPE may be necessary for, say an emergency situation. We have an emergency situation, we don't have any choice. There was a chemical spill, we put on our PPE, rubber suit, rubber gloves, face mask, respirator, whatever, and, clean it up. Maybe we've discovered there's a new engineering control, but until we get that in place, again, we have to wear our PPE. Again, various reasons that we wear that personal protective equipment, and always a good idea. Then this last page is, again, some of those ways of controlling that health hazard. We said we could provide ventilation. So for dust, we could ventilate better. For cold, we wear proper clothing. For heat, proper ventilation. Change the work schedule so you're not working 12 hours a day in 100-degree heat. Personal protective equipment. We've got some new hard hats coming out nowadays that have fans in them to help keep the temperature down underneath the hat. Noise, reduce it at its source, put it in some sort of enclosure, wear personal protective equipment. Biological hazards, train the employees, personal protective equipment, good sanitary facility with good housekeeping habits. Again, like I say, you can look through that list. Just something to think about as far as some different ways to control hazards. And so the last thing would then be to look at the handouts, and we said it was number 2, the OSHA job safety poster or OSHA poster. Again, it says it's the law. And so it gives some rights there. It says, you have the right to notify OSHA or your employer about a hazard that you think exists. OSHA inspection, if you think there is an unsafe thing the company hasn't corrected, you can actually participate in the inspection to see if you agree or have some input. Then if you file a complaint, you also have the right to file a complaint within 30 days if the company retaliates because you filed with your rights under OSHA. It says also that your employer has to post this notice someplace. And then I like the last one. For employees, it says you must comply with all occupational safety and health standards issued under the OSHA Act that apply to your own actions and conduct on the job. OSHA sets the rules. If we don't follow them, it doesn't do any good. Speed limit's 55. If you're out there doing 100, the cop gives you a ticket. OSHA won't give you a ticket for not being safe. They don't really have that ability. You have to be in charge of your own safety in that way. And then it says, your employers have to, provide a place of employment that's free from hazards, and they have to comply with the OSHA Act. Okay, so, again, that's about it for today. Look through day 4, and there'll be a video for day 4 posted shortly.